Okay, so we're in the first of our new topics for this week, and that's binomial products. So you guys may have seen these in algebra in year 9, I'm not 100% sure. But the principles with surds apply the same as what you would have done in algebra. Actually, you definitely would have seen these in algebra. Some of the other parts you might not have. And some of you would remember the rule FOIL, so that's first, outside, inside, and last. So some of you might remember that term. Obviously, you can see it represented here. Actually, I'll use a different colour highlighter. There we go. But the method that I like is called the claw. And it's just simply, if we draw the lines from A to the two terms in the back brackets, and then from B to the two terms in the back brackets, we get what looks like a little, claw, that sort of thing. So, when you go to expand these, just draw your claw, use your claw. So the claw says I have to go multiply A by C, well, there it is there. I have to multiply A by D, there it is there. I have to multiply B by C, there it is there. And B by D, and there it is there. And there's the bell. So there are a couple of special ones that come out. We've got perfect squares that automatically take this sort of this format. So if it's A plus B all squared, it'll end up being A squared plus 2AB plus B squared. And if it's A minus B all squared, it's A squared minus 2AB plus B squared. But if you don't quite get that right now, that's okay. We'll deal with that a little bit with algebra. And the other thing you'll see, just as a time saver, is the difference between two squares. So if we have A plus B multiplied by A minus B, whatever A and B might be, we'll end up with A squared minus B squared. But that's less of a concern for today. I'd rather you guys focusing on just using the claw and using the claw to deal with these surds. So the process is the same doing surds as it is doing algebra. We use our claw, and the claw says first I'm going to multiply 3 by 5, well that's 15. And next I'm going to multiply 3 by negative 3 root 5, so that's going to be negative 9 root 5. And then I'm going to multiply root 2 by 5, so that's going to be 5 root 2, we'll put the surd part last. And then root 2 times by negative 3 root 5 is going to give me negative 3 root 10. Now in this particular example, I can't simplify that anymore. I've got 4 different terms. I don't have any like surds. I can't add and subtract anything there. So that's as much as I can do with that particular question. So then moving on to the next one, I put in my claw, claw, and there's my little crab nippers. So I multiply everything through 3 root 3 times 5 root 2 is going to be 15 root 6. 3 root 3 times negative 3 root 3 is going to be negative, well, root 3 times root 3 is just 3. 3 times 3 is 9. So 9 times 3 is 27. So because there's two surds there that are the same, it'll be the same as going root 3 times root 3 is just going to equal 3, because that's the same as root 3 squared. Then for our next one, we've got negative root 2 times 5 root 2. So that's going to be negative, well, root 2 times root 2 is 2. 5 times 2 is 10. And then finally, a negative times a negative gives us a positive. So we're going to have negative root 2 times by negative 3 root 3. So I'm going to end up with positive 3 root 6. And so that then is going to simplify. I'll deal with my numbers first. So I've got negative 27 minus 10, so that's negative 37. And 15 root 6 plus 3 root 6 is going to give me 18 root 6. Like I said before, the perfect squares, you can find a quicker way of doing them. Obviously, I can write this out as 3 plus root 2 times by 3 plus root 2 and use foil or the claw, and that will work. But we can also remember that this is going to take the form of a squared plus 2ab plus b squared, as we saw up here. So if we remember and we can spot a perfect square and we know what it does, that will make the job a little bit easier, because all I do, well, this is my a here and this is my b here, so a squared is going to be 9. 2ab means I multiply a and b together, that'd be 3 root 2, and I multiply the result by 2, so that'd be 6 root 2. And then finally, root 2 times by root 2 is going to just be 2. So I end up with that, and then I can simplify that. 9 plus 2 is 11, so 11 plus 6 root 2. The next one is a perfect square again, but it's just not written as such. But really what's going on here is that's 5 root 2 minus 2 root 3 all squared. So that's going to follow that pattern of a squared minus 2ab plus b squared. If you're not comfortable with this, you can use the claw here and it'll work out just the same. So if I look at that, what I've got there, that's my a, that's my b. So 5 root 2 squared, well, root 2 squared is going to just be 2. 5 squared is 25, so 2 lots of 25 is just going to be 50. And then I go with minus 2ab. So I'm just going to go back and undo whatever I just did there, which moved everything. There we go, that's better. So I multiply the a and b together and the result gets multiplied by 2. So root 3 times root 2 is going to be root 6. 5 times 2 is 10. Double 10 is going to give me 20. And then I square the last term. So 2 squared is 4. Root 3 squared is 3. So 4 3s are 12. And then I can just simplify and collect my like terms. So I've got 62 minus 20 root 6. Now, for the next one, what I've got here is the difference of 2 squares, because I've got the same 2 terms and the only difference is that there's a positive on one and a negative on the other. So it's going to end up equaling a squared plus b squared, where that is a and that is b. Sorry, not plus, a squared minus b squared. So in this particular case, if I square a, that's going to be 4. If I square the square root of 3, that's just going to be 3. And so the answer to that one is just going to be 1. And try putting that in your calculator. See how it goes. It should come out with the answer as 1. And likewise, this last example here will still also follow that a squared minus b squared scenario, because we've got the 2 terms are exactly the same, and they're just the only difference between each set of brackets is that it's a negative and a positive. So if that's my a and that's my b, I just need to square them both. If I square 3, I'll get 9. If I square root 5, I'll get 5. So 9 times 5 is 45. And then squaring 2 root 3, well, the square of 2 is 4. The square of root 3 is 3. So 4 3s are 12. And so now I'll just take that away. 45, take away 12. That's going to give me, 33. And that's how I do those ones. So just going through today's lesson, when we get into the text work, obviously follow the work platform that's there, but once again, the green area is just to sort of make sure you understand the basic ideas, and you can see there's even some algebra ones here just to get you back into the flow of doing the claw or foil or whichever one you like. But once again, this area here, 4 through 7, particularly with you guys being away from school, I really want you to get further through those. But 4 through 7 is where you're going to be pulling up those base skills and getting used to those. Try to use those 2 shortcuts that are there, that are the perfect squares and the difference of 2 squares. Try to follow those shortcuts, but if you can't, that's okay. You can still use the claw and it will still work out for you. And that's all for this lesson.